Hey, Parvati from APL. If no one's asking questions, I have two. One for Emily's, and great talks, all of you. So when you add the tape on top or the polymer layer on top, does that change the amount of voltage you need to get the dust off?
Yes, yeah. So that's sort of why we're looking at a number of different approaches. So often in the literature, you'll see very thin dielectric layers, and kind of looking at, could we go with an all composite device, and how does that affect? By making an all composite device, you are changing the wire itself, right? Because you're diffusing polymer from both sides, and then how thick can we go, and how does that change the voltage? Is all sort of things that we are working on in this sort of second phase of the study.
Awesome. And Kiana, so it's really interesting that that there's such a difference between the vacuum and the ambient measurements. Do you have a sense of how much water there is on the grains that affects the adhesion that much? Like, is it monolayers or like, yeah. Do you have a sense of how much water there is?
That's a good question. We weren't able to measure how much water was on the surface, but because we're cantilevers and the rocks we're attaching are at such a small scale, and was exposed in the ambient conditions for a long time, we do believe that it's a significant enough amount of water that would have affected or increased the adhesion because of that monolayer.
Cool, thanks.
Any more questions? There's
I'll ask a question. I'm curious about the voltages you're putting through. So are you envisioning something like, this would be applicable to spacesuits? Would you be hanging them up at the end of the day and then trying to get the dust off? Are you trying to prevent the dust getting on in the first place? So are you actively sending charges through while the astronaut's wearing the suit? Like what's the vision of what you're going to apply
Yeah.
this to?
Yeah, so this is not something we're looking at in our study, but is something that is discussed quite frequently in the literature surrounding EDS systems. So there's a couple of different operating modes. You could do things like continuous operation, pulsed operation. So continuous operation would be, yes, constantly sort of running this system, or running it for extended durations and having very little downtime. And then there are examples where folks have looked at what happens if you only turn it on for like a minute every 10 minutes or a minute every hour, and how much effective clearing do you need? So I think questions like that are one much further down the line, but would also depend on sort of what the ideal operating mode is. So it may be the case that for EVA spacesuit, you maybe, while the astronaut's wearing it, you don't have to turn it on. Once they take it off, you turn it on, you clear the dust, and you get ready for the next EVA. Versus like in a habitat structure, obviously you never take the habitat off, so that would have to be a slightly different operation mode. And it sort of depends too on how much contamination we're getting during operation. So if it turns out that turning it on only while the astronaut's out of the suit is effective for clearing the dust from the suits, that would obviously be the safest option. But it may be the case that for long EVAs, they're getting so much dust accumulation that it's starting to affect the mobility or usefulness of the suits. Then we might need to think about something like a pulsed or continuous operation mode.
Yeah, the prevention approach.
Yeah,
thanks.
yeah.
So I have a question for you too. So for spacesuit application, spacesuit is pressurized. There may be a small leak, and if you apply 3 kilovolts, any concern on arcing spark?
Yeah, so something like 3 kilovolts would not be suitable for that scenario because of the arcing concern. So that's part of why we're working on trying to lower the applied voltages. I have to be honest, I'm a materials engineer, and I think Micah would be a better person to answer some of those questions. So I recommend you chat with him if you're interested.
Hey, question for you. So I know a lot of this has been focused around spacesuits, but have you investigated kind of applying this to other space composites like MLI, thermal blankets that might be a little bit of a lower bar
Yeah.
to entry than spacesuits?
Yes, yeah. So spacesuits is sort of the easiest example of a very flexible application that I think comes to mind. But the scheme that we've come up with, we think is applicable to any thermoplastic material. So the cross-sectional SEM images I showed are polysulfone substrates. The devices we're testing are high-density polyethylene. So as long as you have that thermoplastic response in the substrate, we think that this infiltration technique will be effective. The development of the conductive network is a little bit different depending on the polymer substrates that's chosen. But yeah, for any, to answer your question, for any flexible substrate which is polymeric on the outside, as long as it is a thermoplastic polymer, we think that this would be an effective technique to create these sort of conductive traces. And I will say this is not the only, EDS was a nice active device configuration, but you could imagine that if those conductivities are suitable for other application spaces, that you could pattern these things in all different ways. And I will say to the MLI point, we actually just sent some samples for the Space Force mission. So these, the polyethylene reduced graphene oxide composite structures are going to be exposed to low Earth orbit for about 18 months here coming up in a few weeks. So we'll have some erosion data and understand what happens when they're exposed to the space environment.
Okay. Ashley. There's a question here. Hold on. This is from Brad Jolliffe. One of the problems of comparing lunar soils to regolith simulants is the extreme reactivity of lunar soils. Using IR spectroscopy, we have observed lunar soils increase their H2O content with exposure to terrestrial air, moderate humidity over very short time scales, minutes. So how long are the samples exposed when you are preparing them for dispersion analysis, or are the samples kept and measurements made in a controlled atmosphere?
Unfortunately, we're not able to keep them in a controlled atmosphere right now. What we do is well, in storage, obviously we keep them in a controlled atmosphere. When we're doing the experiments, we pull them out as quickly as possible and immediately put them into our chamber, to minimize the time that they're exposed. The exposure is a few minutes for sure, but right now that's what our lab is capable of, unfortunately. Hopefully in the future we'll be able to have less exposure, but right now that's what we have.
No more questions. We're going to wrap up the session, and thanks for coming.